All right, let's jump right into it. Today's explainer is basically a high-stakes geological detective story. We're tackling one of the absolute biggest questions in modern science. Have human beings literally changed the Earth so much that we've triggered an entirely new chapter in its history? Welcome to the mystery of the Anthropocene.
Here is our roadmap for today's explainer. 1. The age of humans. 2. Evidence of human impact. 3. The start date debate. 4. The 2024 geological verdict. And 5. Why the Anthropocene matters.
Section 1. The age of humans.
To uncover our first clue, we really need to nail down the terminology scientists are using to describe our place in planetary history. If you're taking notes, you'll definitely want to get this down. The word Anthropocene comes from two Greek roots, anthropo, meaning human, and scene, meaning new, or epoch. Put those together and you get the age of humans. The term was actually popularized back in the year 2000 by the Nobel Prize-winning atmospheric chemist Paul J. Crutzen. He proposed that humanity has become a global planetary force of change, a force so incredibly powerful that it signifies the exact moment humans became the dominant risk to our own survival.
Now, before this proposed age, we had the Holocene. And the defining feature of the Holocene over the last 10,000 years is stability. That massive window of mild, reliable climate is exactly what allowed human civilization, agriculture, and complex societies to flourish in the first place. I mean, we literally built our entire modern world on the back of this environmental stability.
Section 2. Evidence of human impact.
But as our civilization grew, well, we didn't just quietly live within that stable environment. We've left massive, undeniable fingerprints all over the geological crime scene. To measure this impact, scientists defined a safe operating space for humanity, using 9 planetary boundaries. The crucial takeaway here? We have already dangerously crossed 3 of them. We've pushed climate change past safe limits with rising CO2 and methane, we've drastically accelerated the rate of biodiversity loss and extinctions, and we've heavily interfered with the biogeochemical nitrogen cycle, mostly thanks to industrial agriculture. Honestly, humans actually move more earth and rock today than all natural processes combined.
And you know, these boundaries aren't just guesses. They are strict academic thresholds. Scientists use them to find the exact point where human-induced change becomes completely unacceptable, risking catastrophic, nonlinear, and irreversible environmental shifts. The kind of shifts that could just completely kick us out of that comfortable Holocene state we were just talking about.
And when you dig into the data, one year keeps popping up like a giant red flag for geologists, 1950. Around this time, we triggered something called the Great Acceleration. The human population absolutely boomed. We abruptly doubled the amount of fixed nitrogen on the planet. We started mass-producing plastics that are now basically everywhere in global soils, and we built so many dams we stopped a fifth of all global river sediment from reaching the ocean. It's kind of wild to think about, but future geologists might actually dig up a distinct rock layer full of fossilized plastic and domestic chicken bones from this exact era.
Section 3. The start date debate. So, we've clearly left a massive physical mark on the planet. But in the world of stratigraphy, which is the study of rock layers, geologists need a really precise starting point. When exactly did we cross the point of no return? Well, this question sparked a fierce debate. Some geologists argued it started 12,000 years ago with the Neolithic Revolution and ancient farming. Others pointed to the 1780s, when James Watt's steam engine kicked off the Industrial Revolution. And then you have scientists pointing to the 1940s and 50s, using the Trinity test and a dramatic spike in radioactive plutonium found in the mud of Canada's Crawford Lake as the definitive golden spike in the geological record.
But here's the thing. This search for a single start date created a massive scientific headache. To formally name a new geological epoch, you need a single universal start date assigned to a specific rock layer. But human impact, it didn't happen all at once, everywhere at the exact same time. So some scientists argue that the Anthropocene shouldn't be boxed into a single start date at all. Instead, it's much more accurate to view it as an ongoing, unfolding geological event, much like the Great Oxidation event from billions of years ago. Our impact is highly diachronous, which is just a fancy way of saying it's spread out over time and across different geographies.
Section 4. The 2024 geological verdict.
This brings us to the climax of our geological detective story. After 15 years of intense scientific deliberation over Crawford Lake's nuclear mud and planetary boundaries, the courtroom of global geology delivered a pretty stunning verdict. In March 2024, the International Union of Geological Sciences officially voted down the Anthropocene as a formal epoch by a decisive 12-4 margin. Why?
Because declaring a 1950 start date suffered from recency bias. Basically, pinning it to the 1950s completely overshadows thousands of years of earlier massive human impacts, like the dawn of agriculture. It was just too restrictive for a human story this complex.
But wait, the crucial takeaway here is that this rejection absolutely does not mean our impact on the Earth is fake or exaggerated. Even the IUGS stated that the term Anthropocene will remain an invaluable descriptor for science. We might not get a new official tick mark on the geological timescale, but the reality of our immense impact is completely undeniable.
Section 5. Why the Anthropocene matters.
Which leads us perfectly to our final takeaway. Regardless of the official geological timescale, understanding the concept of the Anthropocene is vital for mapping out our future. Accepting it means accepting that humanity is intrinsically linked to nature. We aren't separate from it. Every time we burn fossil fuels or use fertilizers, we are actively shaping the Earth's system. But because we have the self-awareness to see our pollution and resource depletion, we also have the incredible capacity to innovate. We can invent things like solar panels, develop global recycling systems, and intentionally repair the damage to safely manage our planetary boundaries.
You are the future geographers, innovators, and scientists of this world. You're studying this right now because you are the ones who will be dealing with it. Thanks for joining me on this explainer today. Keep exploring, keep asking questions, and I'll leave you with this final, provocative thought. If we are truly the first species in history with the power to dictate the Earth's future, what kind of epoch will you choose to build?